Andrew Rothstein, been with BlackRock for about 14 years. Going to be presenting work that's not solely my own. My esteemed colleagues are in the audience. I got Forrest Senfang and David Durst, who have done the majority of the heavy lifting on this project that I'm going to probably take more credit than is due for. So here's our contact information. I run the advanced data analytics team within BlackRock Solutions within our financial modeling area, and we're definitely recruiting. We're recruiting data scientists, data engineers, generally smart people. I think it's important to understand before we launch into what we've built, why it's awesome. I think it's important to understand who we are and why we're doing what we're doing. So BlackRock is the world's largest asset manager, and I've listed here our mission statement to create a better financial future for our clients. Our mission asks the question then of who are our clients, and you'd be either surprised or unsurprised to find out that almost everybody is a client of ours. Our clients are folks with capital looking to invest, looking to earn returns to meet their financial objectives. I broadly classify our clients into three categories. Institutional clients, so these are banks, pension funds who have lots of capital that they need to grow in order to meet future liabilities. Retail clients, so financial advisors, you, me, people who are planning for their retirements. And then in the solutions space, or what we call solutions, BlackRock Solutions, in fact, is a division that we come from within BlackRock. We offer advisory services and special situation services. So if you think about a lot of the stresses of 2008, 2009, and subsequent, BlackRock was on the other end of the bat phone when bad stuff was happening. So a lot of the technology, a lot of the innovation that we put forth, we're using to help clients both plan for their futures in good times as well as bad. I included a link to our core values, which I think are important to understand. So first and foremost, we're fiduciaries to our clients, which means that the capital that we're investing is other people's money, and it's important to do so. When you're a fiduciary, it's important to be responsible in the decisions that you're making. Certainly passionate about performance. Our clients come to us because they believe that we can earn them the returns that they so need, that we're one BlackRock, that we're a collaborative environment, and certainly core value, insofar as it's abused in the world today, is we certainly consider ourselves innovators. Okay. So I listed this slide as how, but I think it's as much a why as it is a how. In order to be a responsible asset manager, it's imperative that you understand the risks that you're taking on behalf of your clients. So you have to be a risk manager. We've built over the past 25, 30 years a platform for asset management that we call Aladdin. And it's a combination of software and business processes that allow us to invest client money responsibly. Something that I think differentiates us from many of our competitors is that we are first and foremost risk managers. So we view managing the risks associated with the investments that you're making on behalf of a client as tantamount to making those investments, right? So we won't be making investments unless we can develop a deep understanding of what the expected payoffs of those investments are, and we're going to be using quantitative methods to measure and describe those financial investments. So we're definitely, insofar as we're data engineers and data scientists, we're also financial engineers and finance and econometricians. The assets that we invest in on behalf of clients over the years have gotten much more complicated. So the challenge of a financial modeling group is growing commensurate with the complexities of the securities that we're investing in. It's also important to understand that in order to do a good job risk managing and valuing complex securities, you have to gather data that helps you justify your position. You have to gather data that helps you model the complexity of the securities that you're investing in on behalf of clients. So I said here that they're data-hungry beasts that need to be fed and groomed. So how do you build a financial model? Financial model building starts with data. So there's markets data, there's information, there's data about securities. And me and the team that I work on, our background is predominantly in fixed income investing. So in fixed income fixed income securities financial modeling. And often fixed income assets are backed by pools of loans. So I'll invest in a bond, and that bond will pay me cash flow corresponding to the performance of a pool of loans. Now that pool of loans, behind each one of those loans is going to be a person, right? Is going to be an economic actor. So trying to gather data that allows us to garner insight into how those individual actors are going to behave and what the financial consequences of those actions are going to be is how we do a good job managing risks. So insofar as we can take that data and then build financial models, this is not an undertaking that can be done by machines alone. It's certainly enabled and empowered by machines and machine learning. An important facet of the financial model building process is expressing human knowledge, right? It's understanding what are the economic drivers of performance and behavior, and expressing those quantitatively. So feature engineering is, in my opinion, feature engineering is an intrinsically human-driven task that's part of our machine learning data pipeline. Insofar as humans are participating in the process, we need to make sure that they're doing so optimally, that they're focused on the parts that can be done best by humans. And we all have this amazing capability. It's our eyes, and they're connected to our brain, and they allow us to detect patterns. They allow us to be insightful. They allow us to see things and add context and to develop understanding that can be then packaged into financial models and share with our clients. So we've come up with this idea of the bionic financial modeler. So the bionic financial modeler leverages technology to produce higher quality financial models, and does so by engineering for large-scale data science data pipelines. So got a lot of data flowing in, making sure that we're harnessing that data. Make sure that we're iterating, that we're building financial models, that we're iterating over our financial models to make sure that the insight that we hope to garner, the human interaction, the human component of the data pipeline reflects human knowledge, the development of human knowledge, and that we can do both quickly, right? That we can have the machines go really, really fast, and then they can tell us what the algorithm suggests, and we can learn from that and engineer stronger features that we can then feed back into the system. More iterations means higher quality financial models. It means deeper insights into the future. So when I think about my experiences as an engineer, as a software developer, got a bunch of years of Java development. I probably have more years of C++ development than I'd like to admit. I've done a lot of development with Perl. When Spark came on the scene, we decided to jump into Scala to try and figure out what it was all about. Why is it cool? Why is it not cool? What are the challenges? What are the opportunities involved in pursuing this language? And we have very positive things to say about it. I often think now as a Scala, and I consider myself a Scala developer, I wonder how I could ever have tolerated the boilerplate and the ceremony of Java, when in fact that was an improvement upon the C++ experience that I had, right? So Scala is awesome because it allows for, it's inherently functional but object-oriented programming language that allows for succinct expression of complex data processing tasks. And when you marry Scala with Spark, you can start doing those data processing tasks at very high scale. It's got an awesome type inferencing system. So it's only once you've experienced the epic fail of a dynamic programming language with 1,000 developers and thin unit tests that you can really appreciate the value of a type-safe language, of a statically typed language. Scala here, the awesomeness of Scala's type system is that you don't really feel it. The thing that I've always found kind of crappy about Java's type system is it's so pedantic, it's so verbose. It requires so much ceremony. And the type inferencing system within Scala really allows us to write succinct bits of code that are in fact type safe. Spark as a Scala, when I think of Spark as a Scala DSL. So Spark really allows you to express big data pipelines. It allows you to express big data pipelines without leaking, without the distributed data processing engine, without its abstractions leaking that badly onto your code, which I think is super awesome. So it allows us to really manage complexity and to do so scalably. We are all Hadoop developers. Again, you have to understand what it's like to manage a data pipeline of tens to hundreds of Java MapReduce jobs before you run screaming with your hair on fire towards anything that looks better. We did a whole bunch of work with Apache Pig as a DSL on top of Java MapReduce in our anger. And Scala and Spark have really together offered us a really pleasant solution to the challenge of writing scalable, complex, big data pipelines succinctly with minimal boilerplate. And we're really excited about the distributed data primitives that are arising in the Spark community around things like data frames, the RDD concept, the resilient distributed data frame, data frames proper, and the Spark SQL component that sits on top of them. You got to remember, we're finance nerds here, so a good majority of the people that are in our blast radius are going to be, give me SQL or give me death. So this is a real great way for us to innovate and not drop all the rest of the people that we want to bring along for the ride. And we're really excited about the prospects of doing more lower latency stuff with Spark streaming. And a lot of the financial modeling that we had been doing prior to MapReduce was done with R and SAS and S+. So Spark R is going to function as a great bridge for some of our older school financial modelers and econometricians to get them onto the next great thing. So when we think about building data pipelines and doing data science, here are some of the things that I really want us to bake into our solutions. It's got to be fast. It's got to hide complexity, right? It's got to hide ceremony. It's got to be a pleasure to program in. It's got to be visual, right? It's got to tickle our visual stimulator. It's got to tickle our optic nerve, right? Because that's a really awesome and powerful thing as humans that we have. And it's got to be this virtuous cycle of human knowledge development augmented and enriched with machine learning. The bionic financial modeler, that's what we aspire to. Okay, so I'm going to talk a little bit about two different components that we've either contributed to or built out and released in the open source community. First, we're going to talk about the human-computer interface. So we're going to talk a little bit about visualizing high-dimensional data sets and a cool tool that we've put in place that allows us to, again, tickle that optic nerve. And then we're going to focus on a project that we released in the open source called the SBT Spark Submit plugin, which allows us as developers to develop and deploy Spark jobs more quickly and with less cognitive dissonance. So most people in the audience probably have heard of like the V's, the big V, the V's of big data. Oh, actually, I should say, so this work, the work of this segment is from my esteemed colleague David Durst, and I need to channel his excitement. So, big data, and so can you. Right. So when we talk about big data, there's the 3 or 4 V's depending on who you talk to. The ones that we're going to focus on and in our area of finance that are our biggest cross to bear are volume of data. So we tend to have lots of tens to hundreds of gigabytes to maybe even single-handle terabytes of borrower or of loan performance data. And we want to create an environment where a financial modeler or an econometrician can consume that data and garner insights interactively, right? So we want it to be really, really quick. So when we think about our goal, the goal of any data scientist or anyone building a data science pipeline is really to collect a ton of data about what's happened in the past, to develop intuition for what you're seeing in that data, to formalize your knowledge about what's happened in the past, to build a cartoon or a model for what you think the underlying phenomena or process is, and then to ultimately build some awesome financial model that tells the future, soothsayer, right? To make some high quality predictions. So the components that we're stirring in technically into our solution are, it's a big part of our legacy, Spark, a huge part of the big data awesomeness that we want, and then HTML5 and D3 in order to take these forecasts and this knowledge that we want to garner from data and present it visually to allow folks to interact with it. So garnering intuition, to build tools that help garner intuition, they need to be visual, right? And they need to be quantitative. So really, what we're trying to do insofar as we're presenting data to you is we want to take a very large volume of data, try and distill it down into features that we think are financial features that we think are relevant to the model building process. And we want to present them to our users and offer an interactive experience where our users can really dig in and try to build hypotheses for what a good model would or should or would be. And the second part we're going to focus on is once you got a model, how do you know if that model's any good, right? How do you know if that model produces accurate forecasts? How do you know that model is something you're willing to invest upon? So a model that, and again, this is part of the dream, so we get to say lofty things like a model that automatically produces accurate forecasts and business users can leverage to make educated decisions about the future. So when we think about it as like an intellectual pipeline, these are the different stages that we're predominantly focused upon. So here's the reality of what we rolled up to in 2012, 2013, right? And as a data scientist, you're like, wow, it's a REPL. Or as a software engineer, you're like, wow, it's a REPL. That's amazing. That's awesome. A language as complex as Scala with a REPL. It's like C++ with a REPL. Wow, that's amazing. And then all the econometricians have left already. All the finance people have left already. So we need to figure out a way to put a happier, more interactive face on the stuffs that we're building. So one thing that we built that we have not yet open sourced, although I don't see any reason why we wouldn't figure out a way to carve out the open sourceable parts of it, is a system that we call DaVinci. As an R developer or as a SAS developer, the first thing you do after you get your data frame is you run whatever the analogous routine is for summarize, right? Give me all my univariate statistics on every column of my data frame. And if you're really enterprising, give me some bivariate statistics, right? Show me how individual features correlate with each other. So what we did is we built a system with Spark that takes an arbitrary data frame and renders visually univariate statistics over each of the columns of the data frame, as well as something we're not showing here, which is bivariate statistics. So you could see a parallelogram and you can sort of try to experience the ways in which the features are interacting. Something that was a little bit more visual or a little bit more interactive than DaVinci that that already existed in the open source is this idea of a scatter plot matrix. So what we did here was we connected the Spark job server, which is something I'm going to go into a little bit of detail about, to a D3 implementation of a scatter plot matrix, which will allow us to explore and interact with potentially very high dimensional data. Try to, again, build that intuition for what's going on in this very high dimensional data space that I need to start building financial models with. So I'm going to show, so we have two versions of this. One that's on-premise that I'm going to show that has a mortgage data set inside of it, and another that's running on EC2. Right, so the Spark job server and all the work that we've done on the Spark job server has been committed back to the community. And the EC2 example you can spin up for yourself and or plug in your own data sets. The EC2 data set is going to show some airline data, and our on-prem demo is going to show a mortgage data set. Okay, let's see. So here's the airline data. So if I could orient you to the UI, it's essentially a collection of features, right? It's a very, very big data frame. And you get to pick which of the features you want to render. In the scatter plot matrix, at each row and column is essentially a scatter plot of feature X versus feature Y. So along the diagonal, you're sort of seeing a histogram, some form of histogram along the diagonal. Another thing we've added in here was we did k-means clustering on the whole data set. So the coloring of the corresponding dots correspond to the class in the k-means clustering. So we did for k equals 6, and so this is our scatter plot matrix. Now what's really cool about the scatter plot matrix is not just that you can see this. This by itself is not really, I mean, it's cool, it's interesting, it's insightful. The colors really add to the experience. But what I think makes it really, really awesome is this concept of brushing and linking. So each of the data points exists in all the different dimensions, and they're connected. So it's really important to be able to say, like, for instance, the arrival delay. So you're going to have a collection down here of observations that correspond to small but not zero delay. And it's interesting to see where in the other dimensions, in this very high dimensional space, where do those other points appear? And what's more, as I move my window, it's interesting to see where my points are migrating to in all the corresponding other dimensions. Now, I'm sure if I knew more about the airline business, I could spin you a tall tale of how amazingly intuitive and awesome this is. I don't know all that much about this underlying data set. So I'm going to try and switch to a data set that I know much more about, which is our mortgage data set. Another important thing to recognize is that in order to render this visualization, right, we're talking behind this data set, behind what you're seeing here are, depending on the data set, tends to hundreds of millions of observations. And to do that brushing and linking with hundreds of millions of observations, we haven't yet figured out how to make it interactive, right? So what we're essentially doing is sampling down. We're taking a random sample of anywhere from 100 to 1,000 points, depending on the power of your laptop, to try and, again, build intuition for a subset of the data. And and we also added this notion of resample. So if you want to, let's go back to this one. If you want to get another random sample of the data, it's as straightforward as clicking a button and waiting and praying that the demo gods are on your side. Okay. So in our mortgage data set, so now this is a little bit more applied in the financial modeling space. So on behalf of our clients, we invest in mortgage-backed securities. Those mortgage-backed securities are backed by a pool of mortgage loans. Each one of those mortgage loans, we know a whole bunch of features about the loan and or the borrower. We don't know the borrower's name. We don't know any personally identifiable information, but we know a bunch of facts about stuff that showed up on their mortgage application and facts about the property, the underlying property that's functioning as the collateral behind the loan. So it's really important when we're building financial models for how we think these securities are going to perform to understand what the behaviors of those underlying borrowers are going to be, contingent on a forecast, say, of the macroeconomy. If we think rates are going to rise, if we think rates are going to fall, how is that going to impact borrowers? What are the decisions borrowers are going to make? And what are the financial consequences of those behaviors? So some of the typical and important features that you'll get in a mortgage data set are FICO, it's the credit score of the borrower, the rate that the borrower is paying, its rate, OLTV, the original loan-to-value ratio. So how much money did you borrow versus what was the value of the property at the time that the loan was originated? DTI is the debt-to-income ratio, so a direct measure of ability to pay. And we did a k-means clustering on this, and you can see that sort of the pink cluster is a very interesting cluster. It corresponds to low FICOs, right? So these are the more credit-constrained borrowers. Let's take a look at them by themselves. They tend to have LTVs all over the place. They tend to have debt-to-income ratio focused right in the middle. They tend to have balances. Unfortunately, our balance line sort of gets cut off here. The underlying data set that we're using here is a public data set from Freddie Mac. So Freddie Mac's one of the big government-sponsored entities that pool mortgage loans. And this is a data set of very high credit quality borrowers. In the balance space, in order for you to be eligible for a Freddie Mac loan, you need to borrow, depending on the area you live in, you need to borrow essentially less than there's what's called the conforming limit. So you need to be borrowing less than $417,000, and that's sort of like this implied horizontal line on the balance screen. In the LTV space, there's often a cut at 80 points, right? Because again, the standard loan is for less than 80 LTV. Once you go over 80 LTV, once you're borrowing more than 80% of the value of the property, all sorts of other complex things kick in for you. So what I really like to do when I'm looking at these data sets is sort of what I did with the Airline data set, which is to try and get a feel for how as I move over a distribution of one variable, how that impacts the distribution of other variables. Again, to try and remember, we're in the business of trying to build financial models that are going to predict and that are going to forecast how these borrowers are going to behave based upon what we know about them. And this represents what we know about them. Okay. So now, how do we do it? How do we do it? How do we do all this awesomeness? So the Spark job server is a component that we used in order to build Spark-enabled web applications. One of the challenges in the Spark framework is that all of your data frames are tied to a single Spark context that's running in your driver program, and your data frame can hit disk, and it can survive the run of a job that way. But if all you have is a handle to a data frame, and your program exits, then that data frame goes poof. So the Spark job server is a long-running process that essentially embodies the Spark context. So you can create data frames that are sort of long-lived, and you can interact with them in RESTful ways. So we reference here on this slide, we reference the Spark job server. It's available on GitHub, and all of the demos well, the airline demo, all the infrastructure for the airline demo, has been contributed back, and you can take a look at that yourself. In general, the idea is that you deploy your web server, your Spark server. You can build your job, the code that corresponds to your job. You can upload the code that corresponds to your job to the Spark server via post request. And then you can interact with the assorted classes that represent your Spark jobs or your Spark tasks via a RESTful API with Ajax. In the slides here, we have the instructions for replicating the external version, and also instructions for how you would go about replicating this on-premise for yourself. Okay. So the next part I'm going to talk about is trying to do this more straight through from an engineer's perspective, right? Building a data pipeline amounts to writing a ton of code, building that code, deploying that code, and making sure that when you run that code, you run it in a way consistent with what you're expecting, right? A lot of these stages in your pipeline are going to be parameterized, and you want to make sure that when you build your data pipeline and you hand it to Bob or you hand it to Sally, that Sally can replicate your work, right? And there's all these settings along the way that you're going to want to convey to Sally, and the best way to do that is to figure out a way to get them into version control, right? So a big part of building straight through Spark Analytics is taking the deploy and run stages, codifying them as code in your project. So what we built here. So first, now we have to understand the environment in which we're operating here. So this is what people think we do, right? The minority report, where we're waving our hands and data frames are flying hither and yon, and we're masters of the universe with jacked into the matrix, right? When the reality is probably something a little bit more like this, right? Where we're doing a lot of hard work, right? Staring at code, debugging complex data pipelines, debugging distributed systems. I'm sure everybody realizes debugging distributed systems is not it's not 2x difficult debugging a not distributed system. It's more like 10 or 50x complicated. So we need to make sure that, again, that we're codifying the way in which our applications are being run. So here's the canonical example of why MapReduce is so awesome, right? It's the way you explain MapReduce to people who haven't read the paper, right? And in and of itself, each one of these stages is relatively straightforward, but when taken together, amounts to a really complex distributed data processing engine. So we need to make sure that, again, we're building tools that help us meet the complexity of this challenge in a reasonable way. So when MapReduce came out, when Google published their paper, I closed the link. I found the original presentation, the Dean Gemwat presentation, and they're talking about MapReduce, and it's super duper awesome, and they talk about how easy it is, right? It's easy, it's really easy, because of all the complexity of the underlying distributed system, the GFS or the HDFS bit, that's all hidden from you, right? The scheduling of your mappers in a data locale aware way, that's hidden from you. Employing thousands to tens of thousands of machines, right? It starts feeling a little bit more like that minority report view of what we do. But you have to have the perspective of where they were sitting, right? This is much easier, but it's much easier compared to what the alternative was without it, right? So here, word count is super easy. So here's the canonical example of word count coded in Java. Right, so it's easy, but it's only easy because what was done before it was so unbelievably hard, right? Now we've gotten spoiled. This is no longer easy, right? This is no longer straightforward. And also, MapReduce sort of suffers from this. It suffers from this latency concern, where in between each one of your jobs, your data is hitting the disk, right? And that means that the throughput that you're getting is not going to be great if you're trying to do things iteratively, right? A lot of your machine learning exercises are convex optimizations where you're hypothesizing a model, and then you're testing that model, and then you're updating the parameters of your model based on the residuals, right? So inherently, you're doing guess that model, guess that parameters for model, compute residuals, update model, new guess, estimate residuals, new guess, estimate residuals. And if you're hitting the disk in between each one of those stages, you're certainly doing something that wasn't doable before, which is awesome, but you're incurring a ton of I/O at each stage of that pipeline, which is kind of stinky, right? So it allows you to go wide, it allows you to get a tremendous amount of bandwidth, right? It allows you to get all of those disks in your data center spinning and munching on data, but it also makes all of those disks in your data center spin and munch on data, which kind of stinks. So we do big data, but we do it very slowly, right? Waiting for those jobs to finish. We spend a ton of time waiting for those jobs to finish. And that's not really the kind of interactive experience that we want. We want it to be interactive and quick so that you don't lose your train of thought. I thought this was a good idea, and here was my test, and it was either a good idea or not a good idea, and now what's my next 3 ideas that I want to try? So Spark really was an awesome turning point for us because it allowed us to do these more machine learning, iterative data pipelines in a way that you didn't incur disk I/O at each iteration of your, for example, your convex optimization, right? And it's also super succinct, as I was talking about at the beginning of the presentation. So it's definitely not as full-featured as the 5 pages of Java code that implemented word count, but it's succinct. It's simple and it's straightforward, and you don't need to have 1,000 hours of Scala under your belt to understand what's going on here, right? And so this came off of the Spark webpage, and this table here sort of shows how if you're working on stuff that is iterative in nature, how it's a total game changer for you in terms of your latency. So we have happy and productive data scientists. But wait, now we have a new problem, right? When you're doing performance, you're doing profiling of your application, and the component of your application that's super duper slow bubbles up to the top, and everybody jumps on it and fixes it. What happens next? The thing that was number 2 on the list becomes number 1 on the list, right? So the jobs are running quickly, but there's a ton of burnt time from a developer's perspective in making sure that you got your Spark submit command correct, right? And making sure that, I want to run it on this cluster versus that cluster. I want to run it for k equals 6. I want to run it for k equals 13. Making sure that you're getting all of the details correct. And we aspire to be detail-oriented people and make sure that we're getting all of the characters typed correctly into the terminal, but there's definitely a better way. So it wouldn't be a good presentation without an XKCD comic, right? So when you think about the stages of submitting your Scala application, there's essentially there's a build stage. There's a code stage. There's a test stage. The code build test, right? And you're going to be doing that a whole bunch. But then there's a package deploy run part of the pipeline, and that involves typing a whole bunch of characters into the terminal. So what we set out to do is to try and capture more of that in version control and hide a little bit of the complexity around submitting Spark applications so that you could get back to focusing on the contents of your data pipeline and not on the operational aspects of it. So to augment, here's a simple example of a Spark application. So a Spark application that computes pi statistically, right? And here are the Spark submit commands that you need to type into your terminal. Easy peasy, right? Although each one of them is probably about, I don't know, 150, 200 characters. Gotta make sure you get it right. So these commands are, I view these commands as difficult to remember, and no real easy way before the work that we've done to sort of store them. So the first idea is bash, right? Bash to the rescue. Bash will save us. So we'll start writing bash scripts, and bash allows you to generalize certain parts of the Spark submit, which is super duper helpful. Bash scripting rocks, right? And now you've got your collection of, you got your Scala program, and you got your collection of bash scripts that you need to pet and make sure stay functional and operational, right? So bash is great for getting started. Bash to me is like Excel. It's one of those great things to get you from 0 to 1 really, really quickly, but to go from like 1 to 100, really, really hard, right? And sometimes you wish you hadn't gone from 0 to 1 with it, because getting from 1 to 100 is probably more difficult than going from 0 to 100 with a better solution, right? So some of our challenges around bash scripting included environment isolation, making it repeatable. Bash is not great at abstraction and encapsulation, right? It doesn't really have the notion of modules. You can include scripts from scripts to set environment variables. And it's inherently it's not really type-safe language, right? You can type whatever you want into your script, and then it bonks out at runtime. So these are just a small facet of much larger challenges, right? Of what we're really trying to achieve here. We want to be able to build lots of different Spark applications, right? We want to be able to codify the way in which they're deployed. In a single application, you're going to have different sub-modules and different components of your application that are focused on different things, have different dependencies. So you don't per se want to necessarily be pulling in your H-based jars and running your H-based jar downloads if all you're doing is building a viz, right? And also, now you've got the complexity of all the different ways in which you want to deploy this thing, right? This web app, this Spark application that you've built. So we showed deploying to EC2, and we're running a very big Yarn cluster on premise, right? So that single data pipeline that ran the k-means clustering on those respective data sets, right? You want to make sure that you can capture how to run them in the different environments in a scalable way. So Scala to the rescue. So what we did was we built an SBT plugin. So SBT is the Scala build tool. We built a plugin that allows you to specify how jobs are fired. So sort of take Spark submit and hide it behind the SBT plugin coded in Scala. And I'm sort of running out of time, so I'm going to try and go quickly. This shows how simple it would be to take the Spark Pi example and enable our plugin with it. And our plugin will make it so that you can fire the Spark Pi job via the SBT REPL or at the command line with just SBT Spark Pi. And if you wanted to deploy it in a Yarn mode, it's a matter of coding a couple more settings into your build.sbt that you'll include in your project VCS, right? So SBT is a way for building, so for a little bit more background, SBT is a way for building Scala applications. It's coded, turtles all the way down. It's coded in Scala itself. So SBT is sort of like a meta build system. It offers build system primitives, but you can stitch them together in Scala yourself to build a Scala application. It offers a bunch of cool features around build task parallelism, and it's interactive. So it allows for fast incremental builds. It's got a really cool continuous integration mode or continuous testing mode where you can turn SBT on, tell it, I want to run the tests in this. I want to run this collection of tests, and as you're hacking away in your editor, with each save, it's rerunning your tests. So if you're really into test-driven development, it's a great way to do that with Scala. The fact that the the build tasks and the build system is coded in Scala means you get all the benefits of your UI. Of your IDE. So you get autocomplete. We love IntelliJ. So you get that awesome IntelliJ experience when you're coding in your build system as well, right? So it's not like you have to drop to make and suffer through, using Emacs in order to edit your make file. It's extensible, and the reason we included this slide is because it shows how when you want to submit a task onto a cluster that perhaps is running on EC2, in order to use Spark Submit in a cluster to deploy jobs on a cluster, you have to know who you need to talk to. You need to know who the master of, which node is the master of your cluster. And AWS, through their Java SDK, allows you to interrogate for hosts. What's the host that has this tag? So if you set up your cluster in the appropriate way, you can make it so that people firing jobs against that cluster don't need to, again, drop context and figure out, like, what's today's cluster? What's the name of the master? What's the port that the master is listening on, right? You can integrate the AWS Java SDK into your Scala code to hide that complexity from your user. So yeah, code compiles now. No errors. And it wouldn't be a great presentation without the world's most interesting man, right? And last but certainly not least, we wanted to cover the fact that this plugin works in multi-project builds. So insofar as my single data pipeline has a ETL component, it's got a machine learning component, it's got a data viz component, and you want to sort of bundle them all together because you're coding everything in Scala, yay. It's important that you be able to define the various different Spark tasks that you want associated with those individual modules independently, but within the context of a single project. So this is something that we needed, and we were happy to contribute back into the community. So this really ties it all together for us. We want to be insightful. We want to start with features. We want to take advantage of the optic nerve in our brain to do human learning, to do machine-enabled human learning, and we want to make sure that we're doing it in a really efficient way and that we're not wasting time coding boilerplate and that we're not wasting time remembering complicated commands to type into the terminal or REPL in order to repeat the work of our peers. With that, any questions, or thank you for your time. Fire away.
I'm just curious how much BlackRock leverages the MLlib and the graphing libraries of Spark, and kind of the external libraries besides just the core Spark.
We want to leverage them a lot more. The k-means, the example that we did in here with k-means, that was with Spark ML. Our legacy is very much R and SAS, so we're trying to pull our colleagues along, right? We're trying to push them into this new world, and it's challenging.
I'm curious, you use the Spark Submit jobs to submit the actual jobs to the cluster, but do you use anything else for prototyping, like Zeppelin or maybe IPython notebooks?
Yes. We tried out Zeppelin right when they open sourced it, and it's exactly what we want. It's exactly what we want. We're super excited, but the experience is not really there yet. But I think that that's going to be the way in which we take our SAS and our R and our S+ colleagues, and we convince them, really get them over the line to say, like, look, we're offering an interactive experience. All of the complexity of this system is really hidden from you insofar as that same complexity is hidden from you in those tools. So we're really super duper excited about it. I can't say enough positive things about it. I really want it to be awesome, and the experience just hasn't been awesome yet.
Hi. Actually, my question is going to be about the financial part of your presentation.
Sure.
You mentioned you are doing this clustering and trying to predict the behavior of different debt holders, right?
Yeah, mortgagors.
So, as I know that mortgage-backed securities, they are a pool of debts, and investor can get some tranche and expect some return from it.
Right.
So what you here try to predict, you try to predict the default, right? Default of the
There are
mortgage holder.
There are a bunch of different behaviors that the individual borrowers will perform that have consequences to the cash flows of the securities that are created from them. So certainly concerned about credit, right? But you're also actually very concerned, depending on which investments you're making, you're also very concerned about people refinancing their mortgages. If I lend you money at 6% and mortgage rates rally down to 4%, I'm going to get the money that I lent to you back. It's going to be a prepayment, right? Because you're going to refinance down to 4%. So now I had an expected income stream from you at 6% over 30 years, and now the best I can do is 4% over 30 years, right? It's not a realized loss, but it's an unrealized loss, right? Because I was hoping to earn that higher yield from you over that same time period. So that's a decision that a borrower will make that will have consequences to me as an investor. So really what I'm trying to do is I'm trying to get the full story of what are the potential behaviors of the borrower, and then what are the financial consequences of those decisions that those borrowers have to make on the investments that I've made on behalf of my clients.
Okay, so what's your goal here? If you try to understand, you're going to just advise your clients where to put the money, or you're going to make your bets on the moves?
So we're investing, it's not our money, it's our clients' money, and our clients have financial objectives, and we're taking their capital and we're deploying it on their behalf by investing in securities. We invest client money in mortgage-backed securities. So we need to make sure that the securities that we're picking on their behalf, we need to make sure that we understand, or at least we have an expectation of how those borrowers are going to perform in the various different scenarios of what we think the market's going to look like, right?
Okay, I see. So you invest your clients' money and you want to give them as high return as you can, and you get your fees from that. Okay.
Correct.
What format are your end users actually accessing this data after it's been through these Spark transformations? Is it in HDFS itself and they're writing like Python Spark against it, or is it in like a relational database?
Both and more, right? The UI that we present here, the DaVinci UI that we presented and have deployed on premise, they're using that in order to do first round inspection and intuition building around the data set. Again, DaVinci is really not about model building per se, it's about understanding distributions of individual features to allow you to engineer complicated features that you think are meaningful. The machine learning part of the pipeline, to this gentleman's question, we aspire to make it more Spark ML-like to allow us to do it at scale. Currently, it's very much R, so we'll do, in partnership with someone who's more of an R hacker, we'll come up with a feature set that we want to include in a model estimation. We'll generate an extract that's got the full feature set. We'll write that to the HDFS, or we've developed a strong love for Parquet. So we'll write that as a bunch of Parquet files, and we'll allow them then to sample down from there to create an extract that they could load into R to do some sort of convex optimization, right? So that's how we and that's why we're so super duper excited about Spark R, because we feel like right now in our data pipelines, it's a little bit seamed, and it involves a little bit of handoff, and that handoff creates problems. So making it more straight through hopefully will allow us to, iterate more quickly.
So I guess how often do you go from selecting features to refining your model? Do you do it on a weekly basis, daily, monthly?
We aspire to do it more quickly than we do currently. I'd say we do a full-on model re-estimation. There's a large family of models that we're responsible for. So To say that we would do a new flagship model once every 6 months doesn't mean that we're all working on one model over a 6-month time horizon. We aspire to be delivering models continuously. So we're trying to take the folks that we have dedicated to financial modeling and sort of divvy them up to the various different product types and models that we're responsible for to make sure that we're iterating as quickly as we can on the whole oeuvre, the whole collection. Spark, the reason we're so excited about Spark is that it creates the opportunity for us really to take the data pipeline and run it on steroids, right? To really create, and again, this is part of the dream that I maybe glossed over and went a little bit too fast on, but the dream is to be able to synthesize features, do a convex model optimization at scale, visualize the new model, and give the Roman thumbs up or thumbs down on it, and to do that in the context of minutes to hours rather than right now, it's definitely more of a days to weeks type engagement.
Okay, thanks everyone.
Thank you.
So it's lunchtime on the 7th floor, and afterwards at 2 o'clock back